it's me, your fellow, and today we will learn about special products. Before diving into our lesson, let's have a review first on how to multiply polynomials. For example, we have this expression, x plus 5 squared. If you expand it, it is x plus 5 times x plus 5. Now we know that a times b plus c is equals to ab plus ac, and a plus b times c plus d is equals to ac plus ad plus bc plus bd. Now, let's solve the expression using the latter property. This is also known as the FOIL method. The first, the outer, the inner, and the last. Now let us first multiply the first term, or the a times c. X times x, that would be x squared. Next is the outer, which is a and d, that would be 5x. Next is the inner, the b and c, also 5x. And the last terms, or b and d, which is 25. We will combine the like terms, the 5x plus 5x, that will be 10x. And that will give us the answer as x squared plus 10x plus 25. That is how we normally multiply binomial. We just tried finding the indicated products through the use of patterns. Our goal in this section is to understand key concepts related to special products. There are forms of algebraic expressions whose products are readily seen. There are special conditions which make a polynomial special. Discovering these conditions will help you find the product of algebraic expression easily. Let us start with the square of binomial. The square of binomial is expressed as x plus y squared, or x plus y times x plus y, and x minus y squared, or x minus y times x minus y. In your previous grade, you did this by applying the FOIL method, and we also did the FOIL method in the previous example, which is sometimes tedious to do. There is an easier way in finding the desired product, and that is what we will consider here. Consider this pattern in the square of binomial. First, we square the first term. Next, twice the product of the first and last terms. And lastly, the square of the last term. Remember that the square of a binomial is called a perfect square trinomial. Let's take this expression as an example. X plus 5 squared, or x plus 5 times x plus 5. First, we need to square the first term. That will be x squared. Next is twice the product of the first, the x, and the last term is 5. And we will square the last term, so 5 squared. This will give us the answer as x squared plus 2 times 5x, that will be 10x, plus 25. Let's have another example. 2q minus 4 squared. 2q squared minus 2 times 2q times 4 minus negative 4 squared. So that will give us the answer as 2q squared minus 16q plus 16. That is how we get the square of binomial. Let's move on in finding the special product of the square of trinomial. The square of trinomial consists of this pattern. First, the sum of the squares of the first, second, and last terms. Next, twice the product of the first and second terms. Next, twice the product of the first and the last terms. And lastly, twice the product of the second and the last terms. Let's take this expression as an example. A plus 2b plus 3c squared. That will be a squared plus 2b squared plus 3c squared plus 2 times a times 2b plus 2 times a times 3c plus 2 times 2b times 3c. That will give the answer a squared plus 4b squared plus 9c squared plus 4ab plus 6ac plus 12bc. That is all for the square of trinomial. Let us now find the special product for the sum and difference of two terms. The product of the sum and difference of two terms is the difference of the squares of the terms. In symbols, x plus y times x minus y is equals to x squared minus y squared. Notice that the product is always a binomial. Let's take this expression as an example. X plus 4 times x minus 4. So that will be x squared minus 4 squared. That will give us the answer as x squared minus 16. Let's have another example. A plus 7c times a minus 7c. That will be a squared minus 7c squared. That is equal to a squared minus 49c. Let us now try finding a cube of a binomial. Let's take this expression as an example. X plus y cube. Find the cube of each term to get the first and the last terms. That will be x cube and y cube. The second term is 3 times the product of the square of the first term and the second term. That will be 3x squared times y. Next, the third term is 3 times the product of the first term and the square of the second term. That will be 3 times x times y squared. Hence, x plus y cubed is equals to 3 cubed plus 3x squared y plus 3xy squared plus y cubed. Let's try x minus y cubed. First, we will get the cube of each term. That will be x cubed and negative y cubed. The second term is 3 times the product of the square of the first term and the second term. That will be 3x squared times negative y. The third term is 3 times the product of the first term and the square of the second term. That will be 3x times negative y squared. Hence, x minus y cubed is equals to 3 cubed minus 3x squared y plus 3xy squared minus y cubed. Now, you know how to get the special product of a square of binomial, square of trinomial, sum and difference of two terms, and a cube of a binomial. I have pasted a link of some exercises that you can practice on for finding the special products. It is in the link in the description below. Congratulations, fellas! Once again, I'm your fellow. See you on our next math session.